After knowing electric field due to an electric dipole at an axial point and at an equatorial point, how about at a general point? Clearly, I have no obligation to keep my point specially on the axis or the equator all the time. How about a general point r theta? What does r theta mean? Or x theta in this case. I have a dipole P. The point happens to be x away, the m. Can you notice? And the angle is theta. Okay? This is my axis and I'm interested in what is the value of field at point M. All right, let's start. Dipole moment P bar is a vector. It should behave like a vector. It should follow all the rules of the vector. Enter resolution. Can I divide this vector into two parts? Part 1 and part 2. What is this part 2? This, can I say, is P sine theta vector. This, can I say, is P cos theta vector. I broke my dipole moment vector into its components, P cos theta bar and P sine theta bar. Why would I do that? Well, the point M, which happens to be a point called x comma theta, happens to be a general point for the dipole P. But the moment I broke my P into two components, this general point M just became special individually to both the components. Isn't this point M at an axial point of P cos theta? Agreed. Isn't this point M at the equator of P sine theta? Agreed. How about I find E1, which is due to the axial effect of P cos theta. What's the formula, guys? 2kp by r cube or x cube, but it's not P, it's P cos theta. So there you go. 2kp cos theta by r cube. For the equator, clearly, there is no minus sign in this. Why? Because I have already catered to the minusness of the formula. All the minus sign was suggesting was that the direction of the field and the dipole moment are opposite. There you go. P sine theta is pointing downwards and E2 is pointing upwards. Agreed? So I have two perpendicular components E1 and E2. And guess what? What's the net field? Under root E1 square plus E2 square. So if you do that, what comes out? K comes out, P comes out, X cube comes out. What's inside is sine square theta plus 4 cos square theta. And if you club one of the cos square with the sine square, it becomes 1. Hence, the answer is Kp under root or 1 plus 3 cos square theta to the power half upon x cube. Did you understand that? Perfect? Good. So this is expression. And guess what? You want to check whether it's correct or not? Put theta equal to 0. If you put theta equal to 0, what is cos 0, guys? 1. So 1 plus 3, 4. Under root 4, 2. 2 kp by x cube. Theta equal to 0 means axial point. Is the formula correct? 2 kp by x cube? Check. Put theta equal to 90. What is cos 90? 0. Kp by x cube. Is the formula correct for equator? Yes. This is the formula for net magnitude of net electric field at any general point x comma theta. For the direction part, very simple again. Tan alpha would be E2 by E1. And if you do that, it comes out to be the Kp cancels, x cube cancels. What you have is what? 2 sine theta upon 2 cos theta, and you have half tan theta. One thing which I want to signify. Produce this line backwards. If you produce this line backwards, what is this angle, guys? Alpha. Why? Vertically opposite angles. And what is this angle? Theta plus alpha. Why? Exterior angle theorem. An exterior angle of a triangle by producing one of its line is the sum of two opposite interior angles. That means not only I know the direction, I know the direction of the net electric field with respect to the dipole moment also. So the E net makes an angle theta plus alpha with the dipole moment vector.